Today I'm going to look at LeetCode question number 100, same tree. Given the roots of two binary trees P and Q, write a function to check if they're the same or not. Two binary trees are considered the same if they're structurally identical and the nodes have the same value. So structurally identical and the nodes have the same value. Okay? So for example here, we see that these trees are obviously the same, so we return true. Okay? 1, 1, and these nodes have the same value, and they have a left subtree, and the left subtree has value 2, and they have a right subtree, and the right subtree has value 3. And if you look at this here, these nodes have the same value of 2, they have the same left subtree of none, and same right subtree of none. Okay, none, 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 none. And same thing for this 3 here. Okay, and nodes of same value, and the left and right subtrees are the same. And what about here? Well, this is obviously false because they're structurally not identical. Okay, so this node here, yeah, that's fine. They have the same value. But if we go to this node's left subtree, this node doesn't have a left subtree. It's none. So they're not structurally identical. Okay, this has a left subtree value, and this doesn't. And also vice versa. And also this does not have a right subtree and this does. So this means that false. And what about here? So they're structurally identical, but the nodes don't have the same value. So this has the same value, and this does not have the same value. And this node does not have the same value to this one. Okay? So yeah, that's how we define if trees are same or not. So let's define some parameters first, okay? Well, let's define some conditions first on whether the tree is same or not, aka base cases for our recursive function. So first condition is if p dot root is none and q dot root equals none, because so basically that means we traverse through the whole tree, at least for that subtree, and we have not found a discrepancy, then obviously then we're going to return true, because at least for that subtree the trees are the same. Okay, because if we go here, check here, and then check here, and then return get to none, check here, get to none, that means we have traversed this whole place, this whole path where these conditions were not violated. So obviously we're going to have to return true. Another condition, whether it's same or not, well, they're different if p dot, here does not be q dot p dot root, so p and q just represent nodes itself. So p dot value does not equal q dot value, then return false. Okay, easy enough. What about structural identical? So if p dot left and not q dot left, so if p has a left child and q does not have a left child, return false. And if p dot right and not q dot right, return false. Okay, and vice versa, same thing. If q dot left and not p dot left, if q dot right and not p dot right, same thing, return false in both cases. Okay, I'm not going to write those down here, but yeah, you get the point. Okay. Yeah, and otherwise these are the conditions you have to check. So if we were to, first condition, if we were to able to traverse to the both trees successfully and not meet these two conditions, then obviously the tree is the same. If this is violated, then return false. If this nodes have same value is violated, return false. If structural identical is violated, then return false. And that's how we're going to go about it. And this is going to be depth first search. And runtime is going to be O of n plus m, where n is the number of nodes in the left subtree and m is the number of nodes in the right subtree. It'll just be linear time, basically. And that's how we're going to go about it. Now to code this up, so we're going to define our helper function, pq, that's going to recursively call p and q. So let's define our base cases first. So if p is none and q is none, then return true. Okay. What about if p does not equal none and q is none, or vice versa, or q is or q does not equal none and p is none, then we're going to return false. Okay, I forgot to cover this case here. And what about having the same value? So if p dot val does not equal q dot val, return false. Okay. And what about structural identical that constraint? So if p dot left equals none and q dot left does not equal none, and vice versa, or q dot left is none and p dot left does not equal none, return false. Okay. One more condition. What about for our right child? So p dot right is none and q dot left is q dot right is not none, or q dot right is none and p dot left p dot right is not none. Return false. Okay. Otherwise, what we're gonna do is left recurse helper p dot left q dot left. Okay, we want to traverse the same locations, same time. Okay, if we're going left on p, we have to go left on q. That's how we figure out they're the same. And if left equals false, then we want to return false straight away, or else right is, yeah, so if left is false, we don't even need to go to right, we can just return false right away. Okay, if at one instance any of these conditions are violated, then we just want to return false. Okay, no, then the whole tree is false. It is not the same. And right. Okay. And return. We're going to call it Q. Okay. Yeah, I think that looks good so far. Let me try compiling it. Okay, let me try a few other test cases. Okay, and I'll try submitting. Yeah, okay, great. Thanks for watching.